I'm James A. Rosen. I work here as a user experience engineer alongside Jade at Fastly. And I'm going to tell you a little bit about a story of how we started deploying our Ember application. And the multiple versions that we went through to figure out how to do this correctly. So, what you're going to learn is a little bit about lightning deployment, which is an idea that was introduced a while back by a project called ember-deploy. Just enough Varnish and VCL to be dangerous. So I know this is a JavaScript made-up, but new language. Live it, love it, learn it. Just a tiny bit about the Fastly content delivery network and how we leverage that, and then putting it all together with all of our tools that we use for continuous deployment. So this is what we're going to end up with. The developer is going to push some content to GitHub. It's going to go through Travis, run some tests, get to Google Cloud Storage, and then Fastly will deliver that to the browser. But it will take a little while to get there. So first, lightning deployment. As I said, this was a concept introduced by Sam Selikoff maybe about a year ago, I want to say, where the developer pushes static assets that are fingerprinted to Amazon S3. And they can do this anytime. It doesn't have just anytime before deployment, and they just sit there. So you might have 50 versions of your app.js on S3 at a time, but none of them, except one of them, are really used by anything. And the reason that they're not used is there's no index.html that points to all those other versions. So you can push up a new version, and then when you're ready to activate it for your users, you push an index.html version to Redis. And then in front of those two, Amazon S3 and Redis, you have some sort of reverse proxy. It could be Nginx or anything that serves the content to the browser. So this deployment works really well. You can push up assets sort of slowly over time, and then lightning fast switch over users to a new version. So I looked at this and I said, hey, reverse proxy, I know that. Just walking through the steps. One thing I should note is that the ember-deploy project got merged into ember-CLI-deploy, which is now the one community standard. And it looks a little bit different, but the concepts are very similar. And there's actually a great talk from EmberConf this last year. If you weren't there, if you didn't see it, look at the art of ember deployment. It's on YouTube. The link is in the end of the notes. So I know reverse proxies. We have one here at Fastly. It's called Varnish. Fastly's entire content delivery network is one distributed Varnish. So I figured let's just take that, that same lightning deployment and stick Varnish in where there was a reverse proxy. Now, one thing you should know about Varnish is the phases that happen. So when a request comes in, the first thing is, you get the receive hook. So you can think of these hooks a lot like an Ember route sort of hooks. They're just different lifecycle events as a request is processed and then sent back to the user. This is mostly used to route the request or do some pre-processing, sometimes to do authentication. The next is fetch, which is what happens when the Varnish, the reverse proxy, makes a request to whatever origin server you have. And so it will look up the thing in cache. If it's in cache, it'll serve it from cache. Otherwise, it'll fetch it. VCL deliver is the very last thing that happens on sending a response back, and you could do some header manipulation, gzipping, those sorts of things happen right before delivery. And then lastly, VCL error, which is our error handling hook. So if the upstream server is down or the content is malformed or something, you can catch an error there. If you want to learn more about Varnish, varnishcache.org has very good docs. Most of the things I'm going to talk about in this talk are just pure open source Varnish. They don't have anything in particular to do with Fastly, so you can do this in your own infrastructure if you want. I'll get to a few Fastly specific things at the end. Varnish is a caching reverse proxy. The caching part means that it speeds up your delivery a lot because not every request has to go to some expensive origin server. And the reverse proxy means you can do fun networking things with routing and stuff like that. But the reverse proxy also means that it's not actually an origin server. You can't upload content to it. It's not It's not a file store of any sort. So you have to put it in front of something that has your assets. Reduce load, increase speed, store content elsewhere. One really neat thing about Varnish is that it has very, very fast purges. So you have all of this content cached in Varnish, and you decide that something is out of date. You can just send a single HTTP request, a purge request, to Varnish, and it will be blown out of cache in 100 milliseconds or less. Very, very fast. So you can keep your content up to date. The way you configure Varnish is called the Varnish configuration language. It looks a little bit like Perl. It's pretty readable to a JavaScript engineer. It's just, you have to kind of know a lot about the API. That's the thing to learn if you're going to be delving into Varnish. So the first thing we looked at was just taking that same S3 and Redis concept and putting Varnish in front of it. And that's it. Just use Varnish as a reverse proxy. And that would totally work. The thing you need Varnish for in that scenario is just to do routing. So the routing requirements of a single page app, do I have a laser pointer here? I do. If you ask for an asset, then that should go to S3 and pick up the asset. If you ask for a different kind of asset, it should do the same. And then because we have real URLs here with the Ember router, everything else under this URL goes to index.html, so we can serve the app. So this is a slightly complex routing scheme, and Varnish is good at this, and so I'll walk you through some ways we tried to do this routing. The first I thought of was, hey, the accept header. If the person is asking for an HTML document, then I'll serve them index.html. Everything else I'll just forward onto S3 and figure out what the right asset is. They might get a 404 if they ask for something that doesn't exist, but otherwise we're going to serve them the page. Unfortunately, no. This definitely doesn't work because browsers don't set accept to text HTML. They set it to ridiculous things like this. So this is IE8. You'll notice nowhere in there is text HTML. There's a star at the end. So yes, text HTML is acceptable to IE8, but it really doesn't want it. So there's no way for us to determine that a browser is actually asking for an HTML page as opposed to an image or JSON or something else. So I kind of gave up on this. Next idea. Hey, that should be an animation. The next idea, let's get rid of the headache piece, is we're going to do URL routing. And at first, this seems really simple. We've got everything that's an asset we're going to send to S3. But we have all of these extra files, like robots.txt and the cross-domain XML and all of these other things. And as new files come into your app, they're not all under assets. And so you're going to be constantly editing this ellipsis here is the headache, right? That list is going to get very long, and you're going to have to keep uploading new VCL to Varnish to handle this. So it works, but it's not great. So then I remembered from my previous days as an Nginx person that there's this cool feature called try files. In Nginx, you say try files, URI, and then a failover. So what that does is it takes the URI from the request, and it tries to treat it as a path on your file system. If it can't find a file with that path, then it goes to whatever that failover is. Now, most people will set that failover to a 404 HTML sort of page, but if you're serving a single-page app, then what you want to fail over to is index.html. Anything that you asked for in your app that isn't an asset, then we're going to serve the page. This is how you write that in VCL. So it's a little longer than the Nginx because there isn't a built-in module, but it's pretty straightforward. So in the error hook, right? So we've tried, we got a request for /billing. We went to S3. There's no asset called billing, so we come down here to VCL error with a 404, and we set the URL to index.html, and then we just use this little marker header to prevent ourselves from infinitely looping in case index.html doesn't exist. And we restart the request, meaning go back to the top of Varnish and run all of your rules again, but treating it as index.html. So look it up in cache. If it's in cache, serve it. If it's not, go look it up from some origin and put it into cache. This works really, really well. But I thought, given we have Varnish, so this is absolutely a working, Redis plus S3 plus Varnish system. But I thought since we have Varnish and we don't have Redis available at Fastly, I mean, we could install it, but we don't have one standing by. Why not try to get rid of Redis and just use Varnish? And we can do that. We can do that with purging. So the system that we're going to do with just Varnish is we're going to put everything on S3. We're going to put all the JS, all the CSS, the robots text, the cross-domain XML, and index.html, send it all to S3. And when a user requests the latest version, they go to Varnish. Varnish looks up index.html and caches it forever, right? So no one will ever get an updated version of your app until you then purge. So we kind of have that same two-phase action where you upload all the assets in one phase, but the caching means that nobody is getting that new content. And then when you want to do that lightning deployment to switch over to the new version to activate, you just purge index.html and Varnish will fetch the new version. This works, but it's dangerous. And the reason it's dangerous is if your Varnish restarts and loses its memory, then your app deploys when it comes back, right? Because it lost the cached version. If someone accidentally makes a purge request to your Varnish, your app gets deployed. So it definitely works, but I didn't think of it as really production ready. Wrong order there. So given that danger, I still wanted to leave Redis out if we could, and I thought, how could we do this with Fastly Varnish? So plain old Varnish, you can actually do it, and I'll walk you through how to do it with plain old Varnish a little bit better. There's a Varnish object called a synthetic, and a synthetic is basically a response that is served directly from the VCL. So I said at the beginning, you can't upload content to Varnish. You have to have it in front of some server. This is kind of a way to lie about that. You can, in the VCL, that logic that you've uploaded, embed a full set of content. Now, most people do this for error pages, right? So if no content comes back from the server, or if the server's down, then you can serve a 503 page from Varnish. And it will serve really fast because it's in memory. It doesn't have to look to an origin. It doesn't even have to check the cache. It just serves it right out of memory. It's really, really fast if you're on Fastly because we have Varnish all the way out at the edge. So you're talking about 10 milliseconds or something, or 20 milliseconds to the edge and back. And so this works. The way synthetics work is they abuse the error control flow in Varnish. Again with the animations. So we're going to do a synthetic for index.html, and we're going to say if the URL is index.html, then throw a 900 error, just a made-up error code, doesn't matter what you pick. And then down in VCL error, we're going to catch that 900, which is what that says, I promise. And this says synthetic, and then this is the content of that index.html. So this also absolutely works. It's super fast, great delivery. But again, kind of a headache because every time you want to update that HTML, you have to recompile your whole VCL and upload it to Varnish. There's no quick, really lightning deploy. It's a long compile step and uploading, and then restarting Varnish. So this is where I started to think, how can we leverage the technology that we have at Fastly to improve upon this? And we have a piece of technology called an edge dictionary. An edge dictionary was at first invented to solve this kind of problem. So let's say you have some VCL and you're doing bot detection, or you're doing an access control list, where you have a whole lot of variables that kind of act the same. They might have a small variation, but it's basically you would write a long if-else chain of 50 or 100 things, and it gets to be kind of a maintenance headache. Well, we turn this into a table. Now, this is Fastly Varnish. This is not general open source Varnish. But this table bots now lets us specify a list of objects that we're going to compare again, and we'll do a lookup. And the nice thing about this is you can add to this table and remove from it without recompiling your VCL. So you can just, through the API, add and remove from this table. And it will automatically happen in real time. So that happens when you make an API request to Fastly to update an entry in that table. It'll be around worldwide in a few seconds. It does have limited storage space, I should say. Like, I don't want to say exactly how many bytes, but I wouldn't try uploading like your entire Ember app. But we can use it for just the index.html. Ember apps tend to have pretty small index.htmls. They're 100, 200 lines, something like that. So we can totally fit that. So what we do is we create a table called app assets that has exactly one entry. And that entry is index.html, and this is whatever your index.html content is. And then in our receive, if we have asked for index.html, then we're going to look up the content and throw a 900 error, like you do for a synthetic. And then in error, we'll catch that 900, replace it with a 200, and serve the index.html content. So now we have content that's easy to upload, easy to update. It serves incredibly fast directly from memory worldwide. And it looks like this. So the developer pushes code to GitHub. Travis CI will build that code, run the tests, and when it's ready, upload everything to Google Cloud Storage, which acts basically like S3. It's just we happen to be a Google partner, so we have direct interconnects inside their data centers, which is nice and fast. And then when you're ready to actually activate that version, you send the new index.html to the Fastly API, which distributes it around the world, and you have lightning fast deployment. So this is a little map of our POPs. Those are basically, every red dot on there is a Varnish node. So it's basically one big distributed Varnish. That is what you see there. So a big global reverse proxy. Happy to take any questions. Here are some of the resources that I talked about. ember-deploy, ember-CLI deploy, which will be doing a Fastly add-on for ember-CLI deploy in the near future if you want to do this yourself. That's the URL for the talk from EmberConf. And this is a great, this was in the Ember Weekly this week. It's a great blog post on how to do all of this just with S3, so no CDN in the front, just all the configuration, and basically it's all of the exact same steps with different technology. So I think it's if you're interested in this, really worth reading through it and seeing how the same exact thing gets accomplished on a different tech stack. Thank you. Happy to take a couple of questions. Senor Martinez.
Hey, so how long does it take for you to deploy your Ember app?
Maybe about 3/4 of a second.
Thank you.
Yeah. Depends on how fast you can type ember-deploy v2.
Trying to follow along, you described an earlier implementation where, I think if I understood, Varnish crashed, then your app would deploy accidentally. What would happen now with the way you have it set it up if Varnish crashed?
Well, it doesn't. But
yes.
no. What would happen now is it would lose its cache, right? So everything would be evicted from cache. It would boot back up and notice that it doesn't have anything in cache. And when you request index.html, it would have, from that Edge dictionary, the very latest content, because that is stored in a sort of database that gets written out globally.
Okay.
So there is a central database that is the sort of canonical definition of what the value of an Edge dictionary is. And when the Varnish reboots, it has already had that written out to VCL.
Okay, cool. So Varnish is independent of the index HTML.
Yeah. Tyler in the back, did I say something wrong there? Okay, thank you. I'm not a Varnish developer. So.
So does Varnish, right, do you look to another host to get the index page? I mean, or does it need to be directly on his
Yeah.
framework?
So the question was, can Varnish look at a different host to get different files? And since it's a reverse proxy, you can have any number of origin servers that it looks to things for. You're going to have to write some routing logic to determine which host to go for. It could be by geographic region, or API requests go one way and asset requests go another. Any kind of routing logic. you can do in VCL. But if you're going to have multiple hosts, or you could just have load balancing. Let's say you had Varnish that just sat in front of like 12 API servers. You could just add them all as one sort of cluster of origin, and Varnish will automatically load balance across them. Got a few in the back.
So is the Fastly table persistent then?
The Fastly table, the definition of the Fastly table is persistent, yes.
So if your server crashes, then
Yeah, if our servers crash, which, I mean, it's a large global network,
My server.
things do happen, then yes, they will pick up from the canonical version. It's not, again, if anyone in the back wants to correct me, it's not instantly globally synchronized. There might be like a couple of them that are lag behind by a couple of seconds. But when they eventually, yes? Okay.
Is it fairly easy then to set up, like, if you've got some get parameter that you want to have a specific index HTML version that you want to load up, you can then do that? So it's not just one index HTML that you're requesting. You, like, say, if you want to A/B test something, or
Yeah, okay. So if you wanted to A/B test, yeah. Again, any logic you can express in, basically, if you could express it in a simple JavaScript, like in the equivalent of an Ember route, then you could probably express it in one of the VCL hooks. So yeah, if you had like a query parameter or a cookie, basically anything that you can store as an HTTP header or as part of the URL, you could do. You could route based on. So we have a module at Fastly where, and you can do this in just plain Varnish on your own. If a request comes in and there's no cookie of this particular, like you name a cookie, then it will randomly generate a 1 or a 0 or any combination of bits for A/B testing and save it as a cookie. All of this in Varnish, so you don't have to do it in your origin server. And then Varnish can read out that cookie and set like some flags on headers to send back to your origins. So you can, if you're familiar with like rack or something, you can kind of treat it like rack middleware, where you can do some persistent storage processing there. But again, if you're just using plain old Varnish and your Varnish goes down, you may lose some memory or something. So you want to do things that are easy to boot from zero. In the back.
How do you handle like having multiple, like injecting meta tags and stuff, like for example, open graph tags, or changing the title tag on the index.html or whatever?
Yeah.
The previous way of doing things, which is what we're doing, you actually are doing it in the app server, so you can replace those meta tags. And
Right.
the HTTP request comes out with OG title and all that business.
So there are basically two ways you could do that. If you already have an app server that's generating your index.html, maybe it's generating a whole bunch of, like you said, open graph tags in the head, or even some JSON blobs from your API to like pre-embed, so you don't have to make so many AJAX requests on boot. That's a great performance optimization. If you have a server in your infrastructure that's generating that, you can just treat that as an origin. So instead of pushing the index.html to your Edge dictionary, you can just have your index.html server, your Ember fast boot server, as one of your origins, and point to that. The other option is a technology called Edge Side Includes. And what this lets you do, so if you have sort of basic template blocks that you want to fill in, holes that you want to fill in your index.html, what you can do is take in a request. And Edge Side Include is basically a way of, it's kind of like an outlet in Ember. You can send back your index.html, and anywhere you want to have one of those little template blocks, you have ESI : and then a URL. And when Varnish gets that index.html, either out of cache or from the origin, and it matches it up with a request, it takes that request and makes a sub-request for each of those ESI entries, and then fills in the response at the edge and forwards it on. So that works really, really well for, if you have some server that can do dynamic, some sort of content generation.
I guess in this case, it would I guess in this case, it would just be a partial HTML request, and
Yep.
it would just be the API as
That's
far
exactly.
as the Varnish cache is concerned, which totally solves that problem. Just
Yep.
say this is where the meta blob goes, and the meta blob is get/whatever.html, and nobody has to know that that's how it works in the back end. Which is awesome.
From the back, Docker Tyler, are those serial or parallel ESIs?
They are serial currently.
Okay.
Which is unfortunate.
All right.
But they can all be cached separately
Yes.
and purged separately. And if
Yes.
they're into cache, that's
And it's a
less
really fast
requests to
serial.
origin.
Nice. There was one this way.
Hi. So for the deployment process, right, you explained kind of the plain Jane version way of doing it with just Varnish. So I have a two-part question. One, what is the mechanism that you would recommend to write the VCL and then maybe restart Varnish? And two, when that happens, does it also purge the rest of the cache? So it obviously, right, so the index is in the VCL and it's being served from the VCL, right?
Right.
When Varnish is then reset, is the rest of the cache gone? Does it have to recache everything? 'Cause-
So no, writing new VCL does not purge cache. So you can update the VCL, and this is both plain Varnish and anything on Fastly. Updating VCL leaves everything that was in cache in cache. You may have new rules on how they're processed, but the things that were there are not evicted. A lot of people, when they update their VCL, then follow it on with a purge all, so that they do evict everything from cache, so that they can be sure that all the rules are followed, properly and things are cached correctly. But that's optional, and you don't want to do that if it's going to, really hurt your backend infrastructure. But your other question about how would you write VCL? You could do it with something as simple as handlebars or something, right?
Yeah, I'm assuming it's some sort of custom script or mechanism that you write to then bring in the VCL configuration into your servers, right?
Well, we, the UX team, don't do any VCL like on-the-fly writing because the Fastly API does that for us. We just, again, update that edge dictionary and it will write it. It's just any old templating language that you want.
So there's no like open source, like something that we could use.
I don't
for
know
this?
of a. Yes, Tyler. Better person to answer.
Loading and reloading and changing VCLs inside Varnish, you would typically just do with some of the tools that come along with Varnish itself. So it's essentially just a file that's on disk, and you go Varnish admin, et cetera, in order to load that particular file and swap it out with the one that's in there right now. So.
Oh, one last from Dale.
So how do you handle CORS settings? Do you put them in Varnish?
Great question. How do you handle CORS settings? So I think you're alluding to the fact that they sort of have to be per domain. Is that what they have to? So CORS is all done through HTTP headers, so it's really easy to do in Varnish. I told you about the final hook. Where did it go? VCL deliver, if I can find it, is for post-processing. And that's a great place to set up response headers that you want to add. So we just have a set of hard-coded response headers for that stuff. If you wanted to have something more dynamic based, like if you were serving the same Ember app on 3 or 4 different domains and you wanted to set up CORS headers based on the domain of the request that it came in, that's definitely another thing you can do. You can do exactly the same, just with a dynamic pulling the origin off of the request URL and setting that as a, you could apply it to a whitelist or something and then set it as a response header. So, yep. All right. Thank you all.